One of the most obvious questions for someone to ask themselves when they're looking at a new programming language, especially with the success of languages like Rust and Go, is what are we doing? Why do we need yet another programming language that's a modern compiled language? Well, here's where Zig has some interest for a difference, I guess, in Rust or Go, is that there is a performance optimization matrix that you can look at. So, first up, if you want to have a very tiny binary, there are some advantages over, let's say, Rust or Go. One of the things you can do is you can strip down the size so that you can get these really tiny binaries by removing things. So, for example, if you're developing, you may want the debug symbols so that you can figure out what's going on with your code and debug it. If you want to make maybe a traditional release, you would do make small, and you can make these really tiny binaries that are smaller than Rust. If you want to go even smaller, you can get rid of any kind of thread safety because you're not doing threading. So you have essentially like a knob where it's up to you to go into it and control it. So you have essentially the lower level controls of C and C++, but with a modern compiled language mindset. And so this kind of the best of the both worlds is that if you want to have extreme performance and be able to really get in there and fiddle with it, that's why you would want to use Zig. So where would we want to use this? Embedded systems. So we can see in this case, we have memory efficiency here with a static binary. You can get really small memory efficiency, predictable memory usage as well, because you have control. There's no runtime or garbage collection. And then in terms of the performance, you could get C++ equivalent or even better performance by going in there and fiddling with things. Now, if we look at a comparison between Zig or Rust, for example, you could take a look at the binary size. For example, with Zig, maybe for a hello world, it could be 5 kilobytes. With Rust, maybe it's 300. For a web server with Zig, it's 80 kilobytes. Maybe Rust, it's 1.2 megabytes. So not bad for Rust, but if you're building embedded systems or you're building a very, very tiny Docker container, maybe you do care about this. Now, another one that maybe also could be a factor is that there could be compile time issues. So if you needed to have extremely fast compile times for some reason, I don't know exactly all of the use cases for this, you could get 3 to 10 times faster compile time. So there's some interesting things here as well. Binary startup could be better. So you get a little tweak here with performance, and that might be one of the reasons why for certain problems that you're trying to solve, maybe you solve 80% of them with Rust, which is one of my favorite programming languages, and then you shift over and you get something like 20% of your problems or maybe 10% of your problems with Zig. So I think that's really the way to think about Zig in the era of Rust in 2025 and beyond, is that it's yet another tool that you have in your tool belt, and you might want to pull it out for certain problems, especially for things like the size of the binary, especially for things like embedded systems, especially for things like really tiny Docker containers.